Children are being left behind in AMR crisis. This matters because they have very high antibiotics use, but there are very few options for children in the PEP lab. We already have very high resistance rates in NICUs. The barrier to combining AMR in children include lack of surveillance data that is visible. If we can't see the problem, we can't address the problem. Our aims were 1, to determine the current state of AMR in children globally, 2, to predict future trends, 3, to develop a visualization tool for accessibility. Briefly, we used the ATLAS dataset to access priority pathogen resistance using the WHO new aware antibiotics classification and predict future trajectory. This graph shows trends over time of overall resistance. The green line showing resistance rate to access first-line antibiotics, amber watch critical important antibiotics, and the red reserve last resort antibiotics.
Here's the AMR in kids dashboard that we've developed. The map shows the countries that contributed data, and around the outside you can see our different analyses of the whole data set. As I hover over different areas, the figures change depending on the reflection of local regional data. For example, the pie chart below shows age breakdown. In the bottom right, you can see the overall analysis of resistance to aware antibiotic groups, which I'll come back to. On the global map, we can compare priority pathogens with resistance patterns in children. Of gram-positive organisms, VRE is well documented in adults, but less visible in children, and shown here are the very high rates that we can see, particularly in Latin America. Compare that with gram-negative resistance, and here's Klebsiella showing high resistance to carbapenems in resource-limited regions, particularly Southeast Asia. Now, if you click on any region, this will take you to the subgroup page, so we'll use Africa as an example. And there's a regional summary below each map, but you can select specific analyses up here. For example, if you want to know which age group is the most at risk, you can select age, showing that infants have the highest rate of resistance to green access antibiotics, but that all ages have increases over the last decade to amber watch and red reserve antibiotics. This trend analysis has allowed us to model the next 10 years globally, and it's concerning for kids. If we look at the trajectory again of Klebsiella, we can see that we're predicted to reach 50% resistance to watch and reserve antibiotics by 2033. And then for country level analysis, this is the most useful data that local policymakers can use. And the value of this can be seen immediately again by showing Klebsiella. The global map, where darker is higher resistance, shows that resource limited settings are struggling the most in all different groups of aware classifications. So this is the first child-focused AMR dashboard. Visibility of local pediatric data is completely critical to inform revisions of local guideline and policy and to target time-sensitive antibiotic access efforts.